As you're probably aware, the most common types of 2D games nowadays are either top-down or side-scrollers. Top-down games are good for creating full detailed environments in 2D. Side-scrollers are good for games that need a weight to represent vertical height, such as platformers. Isometric games are kind of a mix between the two. You can represent both complete environments and emphasize the heights or vertical positions of objects. Today, I'll be going over how to set up an isometric tile map in Godot, with ramps, collisions, and a player character. First, I'll walk through the steps needed to create your own isometric tile set. Then in Godot, I'll set up a basic TileMap layer and a player controller to create a test scene. Finally, I'll show you how to automatically generate collisions for the TileMap. Let's get right into it. Oh, and I'm DevWheel, by the way. So when it comes to getting sprites for your TileMap to use, you have two main options. First, you can download some pre-made sprites. I know that Kenny.nl has a lot of good isometric sprite sheets that you can use for free. I'll leave a link in the description in case that's the method you want to go with. If you already have tiles, feel free to skip to the next chapter. Second, you can create the sprites yourself. To do that, you need to have some image editor handy. I'll be using Sprite because it's what I'm most familiar with, but feel free to use whatever you want. Most should work just fine. So for this video, I'm going to be using 16x16 sprites, but you can pick any resolution. I'm then going to multiply the width by 4, because there's 4 different tiles I'll be making in this video. This first tile is going to be completely empty. The second tile is going to be the main block used to build our level. I'm going to make a generic looking grass block. So I'll pick a nice green for my palette here. Starting at the top, I'm going to draw 2 pixels through the center of the tile, then I'm going to continue drawing rows of 2 pixels until I reach the edge of the grid. I'll do the same on the right side. To complete the top face, I'll do the same 2x1 pattern from each side until it meets at the middle. I then want to select the bottom half of this face and copy and paste it to create the lower half of the tile. Finally, join the top and bottom halves together with straight vertical lines. From here, you can decorate the tile however you'd like. I'll fill in the top face with green and fill in the other 2 faces with brown. Finally, I'll give the grass a bit of overhang and do one last touch up of the sprite. The 2 other tiles are going to be ramps, so select and copy and paste the base tile to the right. Erase the top left corner to create some room, then connect the corners, either manually or using a line tool. I'll fill mine in with a darker shade of green. From here, you can again clean it up however you want. Finally, we'll just copy paste this ramp and flip it for our 4th tile. I'll then just recolor it so the shading matches the other tiles. And this is my final result. Don't worry if yours doesn't look great, you should be able to follow along the rest of the tutorial either way. Oh, and make sure to export your sprite to a file format Godot can work with. I'll be using a PNG. With art for our base tiles, we can start setting up a TileMap layer in Godot. This is an empty scene I just created. I set a custom resolution and background color in my project settings. You may want to do so as well. In my project directory, I have the image with the tiles I drew in the previous section. Let's go up to the top left of the editor and click this plus icon. Search up TileMap. Make sure to add a TileMap layer, not a regular TileMap, those are being deprecated. In the node inspector, we can start setting things up. Before we create a new tileset, go down to the TileMap layer's canvas item settings. Under ordering, we want to enable Y-sort. And under texture, we want to set the texture filtering mode to nearest, because I'm using pixel art tiles. If the art you're using isn't pixel art, then you'll probably want to leave it as is. Now we can go up to create a new tileset. Change the tile shape from square to isometric. Next, we need to set the tile size. This will depend entirely on what resolution your sprites are. Mine are 16x16, so I need to set the width to 16 pixels, and the height to half of that, which would be 8 pixels. Finally, create a new physics layer. Next, we can go to the bottom panel under the Tileset tab to start setting up each tile. Drag and drop in whatever images you've created. We don't want Godot to automatically create the tiles. In this left panel, we want to make sure the texture region size matches the full resolution of each tile, which is 16x16 for me. Then click each tile to add it to the tileset. Click Select, and select all the tiles you've created. Under Rendering, we want to change the texture origin, which essentially tells Godot where the center of each tile is. Decrease the Y value until this orange diamond lines up with the top face of your main sprite. Then select just the ramps. We want to increase the Z-index of these to 1. This will make sure the tiles are drawn in the order that we want them to. The final thing we need to do is add collision to the empty tile. You'll see why we want to do this soon. Go to Paint, Physics Layer. Make sure the collision shape you're drawing matches up with the orange outline. Finally, you can just click on the empty tile to add the collision shape to it. This is the tile map fully set up. If we go into the TileMap tab in the bottom panel, we can select which tile we want to use, and then draw that tile in the scene. One trick I like to use is that if we draw a tile 2 steps up from another one, it looks like it is vertically higher than the tile below it. We can continue this to create what looks like multiple layers of tiles with just one TileMap layer node. Then, using the ramps we made earlier, we can create transitions between the layers, which will eventually serve as a way for our player to cross between them. Speaking of the player, it's about time I create a basic player controller to move around this scene. Even if you already have a player created, I recommend watching this part because there's some important settings you'll want to have for your character. First, create a new character body 2D scene. Of course, I'll be naming mine player. Add in a new collision body and give it a circle shape. I'd recommend keeping the size of this shape quite small. Mine will have a radius of 2 pixels. I then created a basic player sprite. It's the same size as my tiles, 16 by 16. This is quite obviously a placeholder, so feel free to use whatever graphic you want for now. I'll drag and drop it into the scene and make sure the feet line up with the collision shape. I'll also have to set the texture filtering mode on this like I did with the TileMap. Then set the player's z-index to 2 so that it appears over everything else. Finally, under the character body 2D settings, change motion mode from grounded to floating. Now I'll be creating a new player script, so if you already have one, feel free to go to the next chapter. It's going to be an extremely basic top-down controller. So added a new script to our play scene, I'll call mine player.gd, delete everything and create the physics process function. First, let's get a direction by calling input.getVector and passing in input directions in this specific order. If direction isn't 0, then we set our player's velocity to direction times 16. You can change this to whatever speed value you want. If direction is 0, then we want velocity to be 0 as well. Finally, after the if statement, call move and slide to cause the player to move based on the velocity we just set. Alright, now we can go back to the example scene we're working with and add the player. While I'm at it, I'm also going to add in a camera 2D as a child of the player node, so that it's easier to see what's happening. Also increase the zoom a bit because it's a little too zoomed out. So we're getting close to being done. We have a TileMap and player set up, but the TileMap doesn't have proper collisions yet. If we run the scene, the player can freely walk off the TileMap or in between layers. With the empty tile we created earlier, you technically could manually place them around the scene to create your own collisions. That's the most flexible option, but it's also kind of annoying and probably not what you want to do when designing a level. Instead of that, we'll be making a script to automatically place the empty tiles at runtime, creating a boundary around the level without any extra work. So click on the TileMap layer and create a new script for it. We're just going to be implementing the ready function, so I'll delete everything else. First, we get an array containing the coordinates of all filled in tiles by calling getUseCells. We'll then iterate over each of those coordinates. We can then get another array containing coordinates, this time of neighboring cells, by calling getSurroundingCells. Finally, we iterate over this array again. For each surrounding cell, we call getCellSourceID to find the tile source ID of that cell. If this equals -1, then we know the cell is empty and we can create a new empty cell in that area. My empty cell is at the top left corner of my sprite sheet, so it's located at 0, 0. Alright, before we test this out in game, go to debug and enable visible collision shapes. This will let us see what our collision shapes look like and make sure they're correct. Now if we run our scene, we see that, yes, there's collisions surrounding all of the placed tiles, preventing us from moving outside the tiles, or moving from one layer of tiles to another. But if we go along the ramps, we can. This is our finished result. Thanks so much for watching. I hope you learned something valuable from this video and that it helped you in your own projects. The full project is available for free on GitHub alongside a bunch of other tutorial projects I've made, linked in the description. If you have any questions or suggestions, feel free to leave them in the comments. And of course, I'd appreciate it if you liked or subscribed if you found this tutorial useful. I'm DevPoodle, I'm glad you watched this, and goodbye!